Alright, in this video we're going to learn how to do mole calculations of hydrate molecules. So hydrate is a type of compounds usually composed by two parts. One is a molecular compound with a number of water molecules. Hydrate is basically an abbreviation of water molecule. Okay, so here's an example highlighted in blue color here. You can see this look like two compounds. You can quickly challenge yourself how to name the first part CuSO4. Yes, it's called copper 2 sulfate. Copper is type 2 metal and it has positive 2 charge here because sulfate has negative 2, and you can see there's only one copper. So you kind of figure out the charge of copper by looking at the sulfate, negative 2 and positive 2 due to 1-to-1 ratio here. Now, there are 5 water molecules attached to this copper 2 sulfate molecule and forming a bigger molecule, which is called a hydrate. Okay, there are different type of hydrate molecules. Some other case you will find another ionic compounds attached by different number of water molecules. But anyway, usually people name this kind of compound this way. You will name the ionic compound part as it is, copper 2 sulfate, and then you're going to use the prefixes number to indicate how many water molecules here. Like in this case, it's called a penta. Okay, so this is the same number of prefixes as we have learned in molecular compounds or covalent compounds. Okay, and the hydrate here means water molecule. So the whole thing we'll name that as copper 2 sulfate pentahydrate. Now the biggest thing here is this dot. What does this mean? Well, this is really, in the calculation you can think of this as a plus, not multiplication. Okay. So in other words, when you think about calculating the molecular weight of this whole thing, okay, the molecular weight, that means the whole thing. You can treat this entire molecule as one molecule. When you calculate the molecular weight, it should be really adding up the molecular weight of copper 2 sulfate and the 5 water molecules. So let's take a look at this. Okay, how do we calculate the molecular weight? Now let's count. Okay, this is 1 copper, okay, 1 sulfur, and there are 4 oxygens plus 5 water molecules, which is basically equal to 5 by 2, 10 hydrogens, and 5 more oxygens. Okay, let's look at this. So basically, copper plus sulfur plus 4 times oxygens plus 5 times 2 times hydrogens plus 4 times oxygens again. I'm sorry, 5. Oxygens again. So if you plug in all the molar mass of everybody, okay, so copper is 63.55. You obtain all of these numbers from periodic table. 32.06 plus 4 times 16 plus, well, 5 times 2 is basically 10 times 1.01 plus 5 more oxygens. All right, add them up. All of these, you're going to get 249.71 unit is gram per mole of hydrate. Okay, so this is the first question. Now, if you have a 3.01 sample of hydrate, how many mole are in the grams? So this is going from mass to mole. Okay, so 3.01 gram hydrate times how many mole, how many grams down here. So gram and gram cancel. You can see this is dividing by the molecular weight. 1 mole is 249.71 gram. So 3.01 divided by 249. You can imagine this is going to be a relatively smaller number, which is going to be 0.01205 mole. Now, of course, you need to look at the original number, 3.01, which has 3 sig figs, so you should only keep 3 sig figs. Now, these 2 zeros are not significant, so you're going to keep 1, 2, 0. Okay, so the answer is going to be 0.0121 mole. All right. So in this many mole, how many molecules are there in the sample? Well, we already have the number mole ready. Okay, so all you need is just take the mole into molecules and cancel the mole. Okay, so every 1 mole is 6.022 times 10 to 20, 30 molecules. So equals to excuse me, 7.2 to 6 times 10 to 21st molecule. Alright, so next question is, how many molecules of water are in the sample? Well, of course, every question, all of the following questions originated from 30.01 grams, okay? This is many molecules of hydrate, okay? Let's do this question here, okay? In every one hydrate molecule, okay, if you look at this formula again, alright, so the formula shown here tells us in every one molecule of the whole thing, there are 5 water molecules. Alright, so basically, the converting factor you can use here is you're going to take the number of molecules of hydrate times dash line. Now the molecule of hydrate down here, just as usual, okay? And what's going to be on top here is a molecule of water. And the relationship here is every one hydrate molecule are 5 water molecules. So basically it's 5 times of that. Okay, and then the next question is, how many atoms of copper? How many copper atoms in the same, similar to water molecule? Okay, excuse me. In every one molecule of this hydrate, there's 1 copper. So you can do very similar calculation. Like I said, you won't spell out the molecule of the whole word, okay? So you know this is molecule, not mole. Alright, again, same thing. We want to cancel that by having 1 molecule hydrate down here. And you want to have atom of copper. The relationship is 1 to 1. Okay, so it's going to be the same number. Now, you probably can imagine, okay, this type of questions can be asked for anything, like how many sulfur atoms, how many oxygen atoms. It can be even asked to how many total number of atoms in the sample. Okay, let's take a look at this. Since there are 1 copper, 1 sulfur, 4 oxygens. Okay, 1 copper plus 1 sulfur plus 4 oxygens plus 10 more hydrogens plus 5 more oxygens. That's total 21 atoms. So in every one molecule, there are 21 atoms. If I make another question asking you, hey, instead of how many copper atom, I'm asking you in total how many atoms are there in the sample. You would do similar calculation here, okay? But in removing the specificity of the copper and just say, hey, how many atoms? Then every one molecule, there are 21 atoms. Then you multiply this number by 21. That's basically how you do this type of calculations, okay, with the hydrate molecule.